The geometric sequence a1, a2 and so on has common ratio r. The sum to infinity of this sequence is 5. Question A. Find an expression for a1 in terms of r. What is the sum to infinity? A formula is given in a data booklet. It says that it's the first term, which is a1 here, divided by 1 minus common ratio. So a1 divided by 1 minus r. So it becomes 5 is a1 over 1 minus r, hence a1 is 5 minus 5r. A second geometric sequence a1 squared, a2 squared and so on has common ratio q. Question B shows that q is r squared. What is common ratio? It's any term divided by the previous, so we can say that q is a2 squared over a1 squared, which is a2 over a1 squared, but a2 over a1, it's a common ratio of the first sequence, which is r, so it is equal to r squared as required. The sum to infinity of the sequence is 16. Question C shows that this is true. Let's consider the sum to infinity. It is equal to the first term, it's a1 squared over 1 minus q, because q is a common ratio for this sequence. So it becomes 16 is a1, it's 5 minus 5r squared over 1 minus r squared. So that we get in terms of r only as required. Then let's multiply both sides by 1 minus r squared and let's expand this to get that 16 minus 16r squared is 25 minus 50r plus 25r squared. Move to one side to get 41r squared minus 50r plus 9 is 0 as required. Then find the value of r using discriminant. Discriminant is b squared minus 4ac using a calculator. This value and the square root is 32. Roots are negative b plus minus root of d over 2a. So r is 1 or r is 18 over 82 or 9 over 41. Cannot be 1 because it's a common ratio. If it's 1, you get that all terms are equal, which is impossible. It's not a geometric sequence at all. So as r cannot be 1, r is 9 over 41. Hence find the value of a1. a1 is 5 minus 5 times r, which is 9 over 41. So common denominator is 41, and it's 205 minus 45, so it's 160 over 41. The third sequence has nth term given by Cn is log to the base k of an plus k. K is positive integer and k is greater than 1. Question D shows that the sequence is arithmetic. So what is an? It's the general term, and we know that un for geometric is what? u1 times ratio to the power of n minus 1. So we can rewrite it as Cn is log to the base k of a1, it's 160 over 41 multiplied by r, and r is what? It's 9 over 41 to the power of n minus 1 plus k. Which which is equal to, we can use that log to the base a over product is equal to the sum of two logs. And using that log to the base a of b to the power of n is n times log to the base a of b. So it becomes, and let's write this k in front to get k plus log to the base k of 160 over 41 plus log of 9 over 41 to the power of n minus 1, which is n minus 1 times log to the base k of 9 over 41. So Cn is of the form, Cn is C1 plus n minus 1 d, where C1 and d are constant, hence Cn is the arithmetic sequence. It's the general form. Formula is given in a data booklet. U1 plus n minus 1. It's not necessary to be n minus 1. It may be of the form a plus bn. It's very important that a common difference is constant, or you may consider a common difference Cn plus 1 minus Cn, substituting n plus 1 for n and minus substituting n for n. This is the same. We get that it is equal to log to the base k of 9 over 41, which is constant. Hence, it's actually clear that it's a common difference, but let's rewrite hence common difference is constant. So Cn is the arithmetic sequence. The next, let C20 denote the sum of the first 20 terms of the third sequence. Question if find the maximum value of k such that C20 is less than 0. We know that the sum of the first n terms of the arithmetic sequence is equal to n over 2 multiplied by 2 times u1 plus n minus 1 times d. This formula is given in a data booklet. So C20, the sum of the first 20 terms, becomes 20 over 2 or 10 multiplied by 2 times u1 to k plus 2 times log, or we can move n to b squared, so plus log to the base k over this value squared plus n minus 1, and let's split it, plus n, oh no, it's not required because n is 20, so plus 19 log to the base k of 9 over 41. And it's 10 times 2k plus log to the base k of, as the single logarithm, it becomes this 160 over 41 squared multiplied by 9 over 41 to the power of 19. And it is equal to 10 times 2k plus log to the base k of, denominator is 41 to the power of 21, and 160 squared times 9 to the power of 19, and it must be less than 0. Definitely we can divide both sides by 10, and you remember, if you divide both sides by negative, well, you should flip a sign. So we can consider that 2k plus log to the base k of this value, and it must be less than 0. K is a positive integer, and k is positive integer, and k is greater than 1. So using a calculator, x plus log to the base x of 160 squared multiplied by 9 to the power of 19 and divided by 41 divided by 41 to the power of 21. Let's check. Then window, let x be from 1 to 20, y from negative 10 to 10, graph, and we need the x-intercept or root, so zero, left, right, guess, so k is less than 6.80 to 3 significant figures. You can see that for smaller x or k values, the value of function is less than 0 is required, so k is less than 6.80, and since k is positive integer and greater than 1, so the maximum value of k is 6. And that's all for this question.